Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our today's session is how to be prepared for disaster recovery, which will cover the high availability and other new features recently released in database management. I'd like to introduce Derek and Shrikant as the main presenters, and with that, I will hand it over to you, Derek, to get us started.
Thank you, Olivia. My name is Derek Harlow. I'm a product manager for the OCI Database Management Service, and we'll be getting to a quick look at the agenda. First, we'll look at some of the key HA capabilities, how you can get up and running very quickly on uh, being kind of protected against disasters as best as possible and maintain high availability in your environments. And then we'll move into monitoring high availability, primarily through the OCI Database Management Service with some of the new capabilities we have there. And then finally, Shrikant, he'll be able to provide a demo, kind of overviewing some of these monitoring capabilities. So we can go ahead and get started here. So I found this very recently, looking through some of the details around HA costs, and one of the quotes from a Forbes article I've listed here said that according to some of the recent research, on average, downtime per large corporations has hit high as $9,000 per minute. And for higher risk environments in healthcare and finance, they can run around $5 million an hour for certain scenarios that have come up in the environments. And so that's basically looking at the SLAs and costs for being available to the end user. So it can be a very large impact. So you really want to maintain high availability in your database environments. And I'm going to go through a few very quick ways to get started if you haven't already, and then how to monitor those as you continue throughout the presentation here. So looking in general, what is high availability? So really, we're looking at several different key aspects, but really it's having an environment available uh, for the application to connect to, access the data, return valuable information, and have a consistent, cohesive experience for the end users. So it's not only having the data available, but also access to it. It could be performance related, et cetera, where you have a degradation in access in the database. So looking at some of the key aspects of high availability, one of them would be data availability, making sure that access to the database is available even during a disaster or an event. And this could be handled by having a data guard configuration, basically a copy of your data living on another site where you quickly to for continuity for end users on the application. This also could be potential data protection, so you don't have data loss within your database. So if you're constantly making these changes, validating that those are going to be preserved, and you can actually revert back to a specific point in time to really have consistency of data over a longer period of time. And this could be anywhere from a hardware failure running on the database host, could be storage OS related. This could also be impactful from malicious threats coming from the outside, gaining access to your environment through security vulnerabilities or password kind of degradation there with your security aspects. And then kind of holding ransom your environments so you don't have access to those to be able to recover from that quickly. Another aspect would be human error. So if you have an engineer going in doing upgrades, and I've actually been a part of this trying to recover data where somebody went into an environment thinking it was a non-production, but it was actually production. They started running some code upgrades, which dropped some older tables, went through and removed some of well, invalidated a lot of objects on the database. And so we caught that very quickly, and we actually had to go back in time to do a restore of specific items and bring it back to production. So having these capabilities and having proper configurations of HA to really speed up the recovery and retention of data for longer periods of time is really critical in database administration. And so a couple of other aspects to consider. the cost and the risk. So really you want to minimize the cost it takes and the overhead for managing these solutions, validating you have scripts and monitoring capabilities in place to validate that the HA efforts that you've put in are consistent and constantly being maintained. And then also risk the costs associated with a disaster, losing data for customers or end users, and having a large impact on your database availability there. So first I'll cover a couple of the details around configuring HA. So we have a service available within OCI, the Zero Data Loss Autonomous Recovery Service. This really allows you to very quickly get started with backup configuration for your database environments. It's a solution available for multi-cloud databases as well. So it can be Oracle Cloud, it can be with AWS or GCP, Azure. You can quickly configure backups to minimize any impact of data loss in the event of failure for your environment. So you can quickly go back in time, restore tables. If you have a full outage, you'd be able to really quickly get started by bringing the database back up from the backup. It provides data encryption during backups and at rest and storage. And one of the great things about this is the tenancy that this data is collected is a service tenancy. So it actually resides outside of your own storage. So it is secure from any passwords within OCI, any user group. If there's any infiltration, you will still have these backup pieces separated completely from your environment. So you have availability even in the event of a disaster within your own tenancy. So it's an automated solution. You can define policies based on your retention and availability of your database. And then you can also very quickly schedule these backups, whatever fits for your environment. So you can schedule them overnight and less impactful time for your database. So you're not having overhead of the database daily runs as well as the backups included there. So you can define granular access to these backups, define which users can make changes to your database policies, backup retention, backup images, and things like that. So you can be very secure in how you're handling the backups for your environments. And finally, it will utilize an incremental forever architecture deployment. So it's doing basically any changes that are coming to the database, it will roll into that incremental snapshots. So you have availability for longer periods of time, but also a very quick recovery solution. So you're not having to go back for a very long time. Have the backup restored and then apply a lot of the changes to roll forward. You can pick up the point in time to have a very quick capability of recovering your database in a very short amount of time. So looking at some additional capabilities and how this is actually implemented and working for the cloud, I have a quick view of basic regions 1 and 2 with some of the availability domains in there. And then you have your customer tenancy, but then also the recovery service tenancy. That's kind of a logical air gap. So you have this place where you have the secure storage encrypted alongside your own tenancy. So we can have private endpoints configured to allow access of the recovery service to actually connect to the database and begin backups here. And you can do this across your availability domains. And then you can quickly have automation of all of your RMAN jobs, configuration, the backup details. So you don't actually have to have the overhead of managing these scripts, writing new backup jobs, doing purging of your archive logs as they come through. And really, it's kind of a all in one place management solution for your backups. So you can maintain configuration, et cetera, based on your details for your environments. So they are encrypted at rest in the other availability domain or zone. So you have this high availability of the backups. Even if you have a disaster in one of your availability domains, or if there's an issue, you still have access to the backups where you can access, and then a lot of the details where you can restore to another place where available, that's up and available within your region. We can also have configuration of backups on the data guard at primary and standby. So if you are doing backups from the standby database, it really allows this complete solution to really minimize the data loss and the risk of kind of errors within the database. So you will always have these details available for restoring for longer periods of time. And then retention lock, so you can really enforce the backup retention policies. Again, users, once you configure and lock, users can't go in and change these. So you can validate that you will have this set for the long term on configuration of your database backups. And finally, some of the real-time protection, it helps reduce the data loss. And then finally, you can restore again in any source location. So it's accessible from one region to the other, from one AD to another. And you can really have flexibility to restore and get back to the point in time where you need to for recovery of your databases. So that said, a very quick way to get started with the service is you can go into the OCI console. There is a button to configure automatic backups for your environments, and then you can configure utilizing the different configuration details here. So you can schedule the backups, you can provide that service, the autonomy recovery service, and then the policy available as well. So again, there's different levels depending on your availability needs, retention of your backups, and availability of your data. And then once you have the backups configured, you can quickly and easily see that they're available for the database with some of the high-level metrics around data loss exposure, last backup details, failures, or anything like that. So you do have it in context of your resource here whenever you're viewing that within the console. So now we'll take a quick look at DataGuard. So really having this data guard configuration is a copy of your database. And so for physical standby databases, they're a block for block copy of your production database. If there's a failure happening within your primary database, could be availability due to the host that it's running on or the domain, or if there's corruption on your primary database, you can quickly switch over the role and kind of fail over to the standby database, bring that up as your primary, and then have the application pointed to that to fail over. So you can quickly get started and have a much less impact for your end users on the availability of your database. So it's a very uh, hardened copy. Everything is the exact same, and basically the changes on production are getting saved from the redo logs to the archive logs. Those are getting sent over to your standby database environment, and then those changes are getting applied on your standby. So there can be a little bit of a delay there, but as long as we are securely storing the redo and writing it to the standby, we have different configurations of how that process goes to validate that we have this rights protection within the data guard configuration. And so those are basically the configuration options for your sync. One would be maximum availability. So this offers the highest level of data protection without compromising the primary database performance. So really, it's synchronizing your data between the standby and the production database, but you're ensuring no data loss is there in the event of a failure, but you're not syncing and validating writes from the standby to production. So you have the highest performance available there. Maximum availability, sorry. So you're synchronizing there. Maximum performance, sorry, is the highest level of database protection. What this is looking at, the commits on the primary actually occur asynchronously with the apply on the standby. So there is no check that these blocks are being written to standby. So you're having maximum performance. You're not waiting on the calls back from the standby to the primary to validate the changes are being recorded in the standby database. And so on the very far end of that is the maximum protection. So here you're looking at maximum availability and retention of your data on the database, but it provides an additional level of data protection. So in the case you have multiple failure events occurring within your data guard configuration. So this mode will actually shut down the primary database in the event that the standby database can no longer ensure changes are being synced between the primary and standby database. So as you're sending the logs over, the standby is receiving those changes, it's applying those changes, and then it's sending the confirmation back to production that these are being captured and effectively written to the standby in case the production does go down, you have this to fail over on. So those are some of the differences in configurations, and you can quickly set those within the primary database with an alter database command. And then finally, there are some basic metrics available within the console. So you can validate that these archive logs are being sent successfully without lag. And then they're also being applied to that standby without, again, additional lag. And so configuring the data guard within OCI, you can go to your resource page again within the database-based service. On the resources section, there is a data guard association. So you can quickly go in. There's a button to enable data guard. And once you do that, you'll bring up this menu where you can quickly input a name for your data guard configuration, your peer database system. You can provide the region and the availability domain, so you have kind of this separation and availability in case one domain goes down. It's best to put it in another one. And then you can choose your shape here as well. If you want to have a like for like environment as your production. So when you do fail over, you have the same performance capabilities there with your standby. So that's going to be one of the best practices there. And I don't have any specific slides on rack, but I will discuss a little bit further in the presentation as we get to monitoring that. But it is always best to have multiple nodes within your database system so they can fail over in the event that one database instance would go down. You can connect to the other one and still access your database in the event of failure there. So now we've kind of done a very brief discussion about some of the options we have available for configuring HA. It's very important that we continue to monitor HA as well, because that's half of the battle is configuring it correctly, but then also making sure that it is up to date, it is working as expected. So if you do have a disaster, you can fall back on these capabilities to have your data available. And so before we get into the bulk of the monitoring capability, really we need to look at some of the options available to monitor these environments very easily. So as we have been transitioning to the cloud from on-premise, oftentimes there's a very mixed estate of IT. So you'll have on-premises databases, you'll have cloud databases, a mix of both as you transition. But even today, now with all of these multi-cloud capabilities, Oracle database at Azure or GCP or AWS, you can have a fleet that's kind of distributed among multiple cloud providers. And so really to solve that, we have some of the key features and aspects within our services that we provide within observability management to really meet the demand of customers on these mixed IT estates. And so the observability management organization, that's where I work as a product manager with the database management service. We're really trying to provide this holistic view of all of your database performance, system performance, application performance in one single location for you to easily kind of get a full aspect of the performance of your environments. So we're taking telemetry all over the cloud, on premise, the different resources supporting your database systems, from metrics, events, logs, traces, SQL, so whole melts that we provide. And then we're providing this advanced monitoring capabilities on top of those. So with the application performance monitoring, you get end-to-end performance of your application calls down to your database. If you have any webhooks in there, if you have any Tomcat servers, you can see how these access to the database is occurring, find any slowness, and really pinpoint those problems. Stack monitoring gives you a full holistic view of your database system, your application system, all of it together where you get high level monitoring metrics for these details for your hosts. If there's any issues associated and correlations between the infrastructure, that's highlighted very quickly here. Logging analytics looks at logging details from multiple sources to find anomalies, machine learning to up level any issues, and really detect from all of this log data the problems and kind of ties together the solution to or root cause for those problems. And then database management, which we'll kind of discuss today. And then Ops Insights is more of a longer term analysis on a fleet level. So you have a lot of capabilities there to look at capacity planning and forecasting, kind of data lake of SQL performance, and a lot of these other details that they provide within Ops Insights. So specifically for the database management service, um, we provide a single pane of glass for all of your databases. Again, be it multi-cloud, on-premises, and OCI, to really provide you availability, insights, performance metrics, a lot of administration key capabilities to manage your database in one single tool. And so what I think of it as is we bring a lot of the capabilities that Enterprise Manager offers, but we offer it as a cloud native solution. So you can easily and quickly get started with monitoring and utilizing these capabilities and tools on your database. So you're able to quickly get key insights and statistics. We highlight any problems with your environment so you can sort top consumers of average active sessions or DB time and kind of filter those out. You can see if there's any issues with your backup configuration, data guard, and really highlight any of these problems and bring them to your view so you can quickly assess and then fix any of these problems. And then finally, we provide capabilities to running at scale. So fleet management. So we have database jobs where you can schedule for multiple databases. You can run DML, DDL to really make changes across or pull reports or kind of do any ad hoc or dynamic workflows, management capabilities on your databases in one single location. So for the database management service specifically, again, we're looking at a lot of the back-end instrumentation that Oracle provides, but we're building a lot of visualizations on top of that to really provide you this single pane of glass management view. So you kind of get a lot of information in one location for your entire fleet, and you can assess any of the health issues for your databases, kind of drill down on additional details and monitoring aspects to really get the most out of your database fleet. It's cloud native, so it's fully managed by Oracle. There is no overhead. You can quickly start with monitoring on the databases by configuring a private endpoint for connections, or there is an agent route that you can go, which you would have to install an agent and then start the service, but it's a self-sufficient agent, thankfully. And then finally, the use cases are basically monitoring and administrating databases with the service, and then getting that real-time performance diagnostics and integration within OCI monitoring for alarming capabilities. And some of the top level capabilities here, again, is that fleet monitoring and management. So looking at your average active sessions, we have Performance Hub integrated, so you have a real-time performance database activity monitoring. We have the HA health monitoring, which we'll check out here soon. And then we have very granular in-depth capabilities as well, looking at Ash Analytics, SQL details, running SQL Tuning Advisor, doing a lot of this administration capabilities on the database as well. So you can quickly find any problem, any outliers in the performance of your database, and then drill down and make any changes necessary to actually fix those problems. And there's a lot of visualization. So we also have tree maps built into the service so you can quickly address any potential problems. We have short-term trend analysis so you can find any outliers in database performance and really address those issues as they come up. And so then getting into really a bulk of our HA fleet monitoring, some of the new capabilities within the service, we wanted to bring over on the fleet level to allow you to see the health of your database configurations of HA. So looking at backup details, looking at data guard configurations within the fleet, and really being able to quickly assess how those are performing, if they're going to be meeting the requirements to fail over, if you have backups available so you can fail back if there was a disaster, and really seeing everything in one single location. So we have integration with the OCI monitoring service, so you can quickly set alarms on your databases. And if we go to this high availability overview, we have HA alarms specifically set for these databases. You can view those metrics and any outliers there. to quickly see if there's any problems with backup failures or anything else that you have configured for HA alarms. And so this view will really show you an overview of your last backup, if it was successful or not, if you have any um, problems, if the last backup is kind of not started or completed successfully within an extended amount of time. We have views of if data guard is enabled for your databases, and then kind of a destination. So you can see if you're utilizing a recovery appliance or if you have your backups to tape or to disk object storage, you can quickly see and get an idea of what your fleet configuration is. So, really wanting to highlight what this looks like for your fleet. Really great details on the overview, but then the capability to filter and drill down to individual databases in the table below. So, if you are having backup failures, you quickly identify which of those backups are, and then get more information on those capabilities. So we have an additional tab that's specifically looking at data guard. So from the overview, you can go to data guard if you're seeing some issues on your databases here. And then we have a whole view of your configuration. So you can kind of see how the health is of your databases, the configuration of your data guard, if they're being synced correctly. So if you have any high transport lag or apply lag, those changes from your primary database to your standby, you can quickly identify which of those kind of are at risk or have higher elevated times that you can go address, probably figure out what's going on in those environments and kind of mitigate the problem there. And then finally, you can see a redo apply rate as well. So even if those logs are getting transported from primary to standby environment, you could have other processes running on the standby that's causing slow apply of those changes to the standby database. So kind of validating the whole picture of syncing between the databases is occurring as expected. And then we also have a nested view in the table below of your primary database and your standbys. So you could have multiple standby databases configured, and you get a quick view of how the health of each of those are with their configuration details around protection mode, or if you have fast start failover enabled, et cetera, it can be found there. And then finally, looking at your backup reports and details for your fleet. So you're able to see the configuration for cloud databases if you have those automatic backups enabled. You can view your recovery windows of your fleet, retention period, and then the backup destinations, again, to get an idea of the configuration across the entire fleet, quickly find any outliers, et cetera. And then we have a trend line of your total backups here. So you can see over time how many successful backups have been occurring, how many failed backups. And this is where we can kind of group in some of the archive logs to validate that those are getting back up as scheduled. So you have a really good idea if there is any specific problem with your backup service. You can see if maybe it's impacting all of your databases, or if it's only one single database, maybe it's credentials or something else that has changed in that environment to quickly find that outlier. And again, you can kind of drill down these failures to see the individual database details. There's multiple failed backups here. You get more ideas and kind of drill down to that database resource itself to get those capabilities seen. So if you were to drill down to the individual database, it would go to the database homepage, the resource page, where you'd be able to get more information on the last successful backup, some of the details around that. And then you get more of a summary around completed and successful jobs, some visualizations built in to quickly validate if you have enough fast recovery area, your FRA is healthy, so you're making these changes to your database. They're staying in that location, and you're not going to have any issues to fail back to a specific point in time. You can look at your recovery window and your unprotected window to validate you're not at risk at losing any data for your environments. And then again, you can see if your flashbacks enable. And here where you can filter out based on some of the details of your individual backup jobs. So you have a whole list of these down to the individual archive logs. You can see when those are completing, if you have any failures, to get an idea of when you might be having problems with your individual backups. So, looking within the same database, you can quickly navigate to the Data Guard tab. So this is all nested under the same location, which you'll be able to see in the demo later. But you have a good details onto the configuration of your Data Guard, what protection you have for your database, as well as the configuration of fast start failover. But then you get some metric charts looking at the key metrics for their database syncing from primary to standby. So you'd be able to see your committed and rollback statements on your primary database, but then also look at your standby database for the apply lag and transport lag to validate that things are keeping up and synced on the primary database. So you want to validate that the apply lag and transport lag is pretty much very close to zero. And then you can also look at your redo generation rate on your primary database to the redo apply rate on your standby. So any changes that are being made on your production database, you'd be able to see spikes and a lot of redo, a lot of changes going on your primary database. And then you can also see those being applied to your standby database. So you can find any gaps where that might be occurring. So it could be that your archive logs are not being transported to the standby environment quickly enough, or it could be you're not applying them quickly enough once you get to the standby database. And so utilizing these metrics, you get a good idea of where you need to investigate the performance of that standby database. So I briefly discussed it earlier, but really having this rack configuration, multiple instances to connect to your database in the event of a failure on one of them is very critical in maintaining high availability for your environments. So this will take into account your grid infrastructure with CRS, being able to associate the different instances on the cluster, and validating the health of your different instance environments and really making sure that you're not having any problems with the kind of the talking between the instances, which is through your cluster cache and your cluster interconnect. So we have a lot of dashboards that are built into the service. You can quickly get an idea of how many writes are going in one instance versus the other, the workload on one instance versus the other, and then syncing between the two with your interconnect activity. So if there's any long waits there, there might be hardware failure between the hosts, or there could be a problem with the packets, way they're being sent from one to the other. You can kind of work with the sizing and details there to actually get the optimum performance there. So we kind of break this all out so you get a quick indication on what the health is for your environments in rack. But then we can also split this out to see the monitoring status timeline of your individual instances to make sure that those are up and healthy at all times. And then again, look at some of these key performance metrics between the two instances so you can see and quickly compare what the CPU utilization looks like on both of those. Again, looking at average active sessions on both of those, and then looking at IO and memory. So you have a holistic view of the health of your database rack environment and that they are performing as expected over a longer period of time. We also provide an Oracle database system monitoring, so you have full view into the health of your databases. So this is a new resource that's currently available for external databases only, but we will be providing these capabilities with cloud infrastructure within the next coming months. So you'll be able to discover your resources kind of and see this as a whole entity on your cluster. So we have the cluster resource, we have a database which is existing, but then we'll also have ASM resources as well as listener. So you'd be able to see the health for each of these individual components on your database system and kind of validate that they are all healthy, performing as expected. You're not having specific issues. And then we kind of build these visualizations again on this kind of holistic view so you can validate that your entire database system is performing as expected across the board. Again, you can see your availability timeline. So obviously, if ASM goes down, your databases will go down as well. But it's a quick indication that, yeah, my databases are down because ASM has gone down. So the cluster resource specifically, we provide a resource page here now where you can see the availability timeline of your different cluster nodes, and then you can get more details on your cluster interconnect activity again in this view, as well as some of the high-level activity on the hosts themselves. So you can see your CPU utilization, you can see the roles and some of the configuration details for these individual hosts. For ASM monitoring, you can see the detailed analysis of your instances for ASM's availability. You can get some high-level utilization of your disk groups, some of the top consumers of databases within those disk groups, and then you can see an association with the databases as well. So a lot of the configuration details for ASM is available, but then we also have performance metrics for ASM provided now as well. So you can see your response times, throughput, the different databases ASM is servicing, and find any resource-intensive databases or disk groups, kind of pinpointing where those problems might be if you're having a lot of I/O throughput issues on your database hosts. And then finally, you can see the utilization percent to kind of get a good idea of where your storage is allocated and if you need to address any of those issues quickly or not. So then looking at alarm definitions. So again, a lot of these metrics coming into our service for HA Health are coming straight from the database. We integrate into our own namespace as metrics into the OCI monitoring service. So we have these capabilities of quickly getting started by creating specific alarms for your databases. So today we don't have any out-of-the-box alarms available for HA Health. That's something that probably we'll add to the roadmap so we can get quick configuration of last backup status and things like that on your database at the appropriate intervals. But really, within your database resource page, we do have a section where you can see all of the open alarms for your database, what the configured alarms are for your database, so you get an idea of what those are configured as. And so we do have some best practice alarms that you can see what they're set for, the threshold, the interval that they're monitoring on, and the threshold. And you can alter these very easily as well if you need to make any adjustments for your specific environments. You can do so within our console. And again, everything is integrated in the OCI monitoring service, and it's very quick to configure this. I think it takes like the out-of-the-box alarms. Once you're in the console, you can go through that, set your notification, and create these within 10 seconds. It's very quick to get started with the monitoring capabilities there. You can define different notification protocols. So you can send it out to an email. If you have a group DBA DL that you would like to send it out to, you can do that. We have integration into Slack, and you can have a specific URL as well if you need to send it off to another service for consumption. And then you can quickly clone these alarms for a single database to multiple databases. So you can basically select them and then duplicate those to another database to kind of quickly configure those in another location. So if you if there is a gap potentially with the metrics that we collect, we obviously can take that feedback and we can incorporate that into our service where applicable. We work a lot with the customers to actually meet these gaps and fulfill that within our service. But if we don't have anything, you can create a metric extension. Again, today this is currently available for external databases, but as we have agent support for cloud resources, we'll likely be able to extend metric extensions there as well. But really, you're able to provide your own PL/SQL or SQL queries to ingest metrics from the database into the OCI monitoring service, where you can configure your own alarms for monitoring these database details. So you can configure your own collections if there is any gaps within the monitoring today that we provide. All right, and that leaves the demonstration next. Srikanth, are you available now to go through the demo?
Hi, I'm Srikanth. I'm going to demo high availability fleet and key concepts in high availability and data guard area in this presentation. To go to the database management service, it is under observability and management. And under the database management, we have few sub features. This feature comes under diagnostic and management area. Under the diagnostic and management area, we have high availability section. High availability overview page provides database backup and data guard key metrics to provide overall holistic view of fleet level high availability health. It includes, if we see it, last backup status, elapsed time since last backup, data got enabled, status, backup destination, and OpenHA alarms. These visualizations provides uh, quick insights into any database availability issues with respect to backup or with respect to data guard enablement statuses. This visualization at the top level will provide fleet level summarizations, whereas at the bottom, the table will provide individual database resource level metrics, the same metric. We can filter these resources based on out-of-box provided filters from the dropdown, or we can also filter from the top-level visualizations. The next one is DataGuard overview fleet page. DataGuard overview fleet page provides at the top level, it is going to provide in the fleet what are the top 10 databases which are having the longest failover time. If there are any, they will be listed down here. Also, it is going to provide if there is any open data guard related alarms are open in the fleet, they will be listed down here. This page is mainly designed to cover any is to identify and inform any fleet level issues with respect to the data sync. Redo log shipment delay or redo log apply delay can be viewed if there is any issues through transport lag and apply lag visualizations. These visualizations helps to identify any data guard environments in the fleet which has any standby database in the fleet which is lagging behind from the primary with respect to the data sync. Apart from these things, it also provides configuration related details, fast start, failover, and more status. Also, it is going to apply on various standby databases in the fleet. The bottom table is providing these key metrics at individual database level. Apart from these key metrics, it also provides association between the primary database and standby databases, where we can view what is the for individual database, the same fast start failover status, estimated failover time, redo apply lag, rate, redo apply rate, transport lag, and apply lag in seconds. We should be able to view it here. And next, irrespective of whether the database is in cloud or external, we are providing backup details information. This backup status details information is providing whether if it is a cloud database, we are going to provide whether the automatic backup is enabled for the database or not. The second widget is going to tell us what is the recovery window for the fleet of databases, how they have been distributed for various buckets, and retention period distribution and backup destination things will be provided. It also provides successful and failed backups over a period of time in the counts. For a selected period, at this particular time, these many backups have been succeeded, or in case if there is any failure, we are going to see in this time range, these many backups have been failed in the overall fleet of databases. In case if we want to know what are the databases that got failed or that got succeeded, we can view individual databases information in the bottom table. Like earlier, this also is a filterable thing based on the given criteria from the dropdown, or we can even filter out from the above widgets. Apart from the cloud databases, the visualization for external databases is also exactly the same. The only difference between these two sections will be primarily in case of cloud databases, we are providing whether the automatic backups were enabled or not. Whereas in case of external database, in place of that widget, we are providing backup size in GB. Rest of all other things will remain same. In case if something happened and if the backup got failed, and if we want to know more details into it, one can go click on the database link. It will navigate to the database home page. This page will navigate to the backup section. This backup section is going to provide you even more fine-grained details with respect to the backup summary, and when did the last full backup happen, and FRE usage details, flashback, whether it is on, turned on or off, and recovery window and unprotected window. These details will be provided in the individual database homepage. Apart from this key KPIs, it also provides you at what time various backups had been started and at what time it had been ended. What is its result, whether it is succeeded or failed, and what type of backup it is, whether it is a incremental backup or whether it is a full backup or whether it is an archive log backup. Those details we should be able to view it here. In the same section, we also have the facility to view the data guard details. This data guard view details provides over a period of time how my data sync is happening between the primary database and standby database. We can see at the bottom, we have the primary database. In the primary database, how the commits and rollbacks are happening. And because of this reason, how the redo is being generated on the primary database. The same thing, how is there any delay in transporting this redo log to the standby databases will be shown under transport lag widgets. And if there is any delay in applying the received redo log, will be shows up under apply lag. And at what rate the redo is being applied also will be shows up in the redo apply rate widget. For the associations between the standby database and primary database, those associations will be shows up under this table, in this table. At the top level, we are providing what kind of, whether the data guard broker is enabled or not, what is the protection mode here, and whether the fast start failover is enabled or not. This is the quick overview of how the data guard information is being shows up here. In the high availability, apart from the data guard and backup, we also have the rack case where we are going to provide additional information related to the cluster cache. Let's go to the one of the rack database and see it, the cluster cache page. This is the rack database. I'm going to rack database. In the same section, we are going to see the cluster cache. It is going to provide how my CR blocks, average CR blocks receive time and average block, current block receive time. This information can be seen here. Similarly, we are going to see that how many number of blocks have been transferred within a second for both CR and current blocks. Also, it is going to provide how the physical reads are happening and what is the cache block how the cache block transfers are happening. This is a quick overview of the high availability features in the DVM feature. It is going to provide you to view backup related information and setting an alarms to get any notifications with respect to backup failures or anything. And also in the data guard environment, if there is any switchover failover happened, customer can listen on those events and they can make a choice. And if there is any data sync issues, they will be highlighted through various widgets. And also for the same, customer can configure an alarms. And in case of rack, if there is any cluster cache issues and all, customer can configure alarms and they can view historical information in this section. This is all from my side for HA demo. Thank you.
Thank you, Shrikant, for the demo. That was great. All right, so some of the key takeaways, again, there's many different capabilities that you can employ to have high availability environments. We've only covered a couple of those today, but they are very quick ways to get onboarded and validate that you have secure backups and data guard configurations for the long-term capabilities. And really, we do provide a solution to monitor these as you go forward. So after you've invested all of the time to actually configure these capabilities, you also need to kind of have the time set aside to to keep these in mind to monitor the availability of your data guard environments and successful backup capabilities.
There is one question from Raghu. What does long-term backup retention up to 10 years? Raghu, it is in the context of recovery autonomous service where by default that service is offering minimum 14 days and maximum 95 days. That is a normal backup. In case if you want to have long-term backup retention period, you can configure it from 90 days to 10 years.
The next question is, are these features available on XSC Cloud at Customer as well?
Yeah, so the backup capabilities for monitoring on the HA fleet will be available. The system infrastructure capabilities are not available today. We are working on having these within the next couple of months. So we should be able to view the database systems and all of those configurations for the XSCC soon. I will say the caveat, the HA backup is not available for autonomous databases today. Again, we will look at the roadmap and requirements from the customers to actually get to the autonomous database backups details.
Okay, and as a refresher, we just learned that Oracle Data Guard in Government Cloud is available through the OCI console.
Okay, perfect.
Thanks, everyone. So we do have a few more slides on some resources pertaining to some of the tools covered today. So you can find that listed here for some of the backup and recovery resources. And then there's some other ways of learning more with database management. So we have some hands-on labs and some blogs listed here. And this is another link just in general of ways to learn more on the different tools in OCI. So I recommend that you check this out. And so one thing to note is that we have our Day 1 and Beyond series here, which is more one-to-many. But we also do have more customized personal training over a variety of different topics in OCI, as well as more hands-on live labs. And then we also do have Code Innovate, which is a 5 half-day online event where Oracle engineers will help you co-develop a use case. So we did list the emails here if you want to learn more or explore some of these other programs that we do offer. And then lastly, this is our webinar series, but we do have some other Day 1 and Beyond series, such as analytics, hands-on, cloud native, security, and did you know? So please feel free to explore these. And yeah, thanks everyone for joining.